In this video, let us understand how to find out the current through a resistor using superposition theorem. So here we have a voltage source of 36 volt and a current source of 9 ampere. So this is the current I, that is the current that is flowing through the 6 ohm resistor, is to be found out using the superposition theorem. So we know how to apply the superposition theorem when we have different sources, like if you have a voltage source and a current source, we have to consider only one source at a time. So if I am going to consider a voltage source, then we have to open circuit this current source, and when I am considering the current source, I have to short circuit this voltage source. So first let us take into consideration this 36 volts voltage source. So we have to open circuit the 9 ampere current source. Okay, so now let us redraw this circuit. So we have the 36 volt voltage source. Here we have 12 ohm resistor, and here we have 6 ohm resistor, and this will be open circuit. That means the current through open circuit is always 0. Okay, so here how can we find the current? So we can find the current like this. So it is 36 minus 12i minus 6i, that is equal to 0. So 18i, that is equal to 36, and I is equal to 2 amperes. So this is the current which is flowing through the 6 ohm resistor only when I am considering the voltage source. So now let us consider the effect of 9 ampere source. So to find out the current through 6 ohm resistor using the 9 ampere current source, we have to short circuit the voltage source. So now let us redraw this circuit. So this is short circuit, and here we have 12 ohm. This is 6 ohm resistor, and here we have a 9 ampere current source. So what is the current through I then? So we can use the current divider rule. So I is equal to the current, that is 9, into the resistance in the opposite branch, that is 12, divided by 12 plus 6, that is the total resistance. So here we have 9 into 12 divided by 18, and you know this is 6. So I is equal to 6 ampere. This is the current which is flowing through 6 ohm resistor, that is due to the 9 ampere current source. So what will be your total current through this 6 ohm resistor? That will be 2 ampere plus 6 ampere. Why are we adding this? Because we can see here also the direction of the current is downwards. Here also it is downwards. If we had opposite, like if we had a current like 6 ampere and then we have 2 ampere, you know that the resultant current will be 4 amperes. Okay, that will be in this direction. Since this both currents are in same direction, we will take the sum of that, and that will be your 8 ampere. So this is the current flowing through the 6 ohm resistor. So now we have to see whether we can find the power also using the superposition theorem, whether it holds good for the calculation of the power or not. Okay, so now 8 ampere and 6 ohm. So you know power, that will be equal to I square into R. So this will be 8 so 64 into we have, that is 6. So what will be your answer? It will be 384 watts, right? 384 watts. This is the power. So now if I consider the superposition theorem, because of this 2 ampere, if I consider the power, it will be 4 into I square into R. So 4 into 6, that is 24 watts. And due to this, it will be I square, that is 36. 36 into 6, that is 216 watts. Right? 216 watts. So if I take the sum of this, according to superposition theorem, if I take the sum of this, what will I get? It will be around 240 watts, right? 240 watts. So this is 384 watts, this is 240 watts. Actual power is 384, but using superposition theorem, I am getting 240 watts. So that will be wrong. So we cannot find the power that is using the superposition theorem. If you want to find the voltage and current, then that's fine. But power, you cannot find it out using the superposition theorem. So actual power which is dissipated, that is 384 watts.